Good morning, ma'am. Good morning, classmates. We are here to present our report about types of chemical reaction.
Types of chemical reactions. Chemical reactions is a process in which one or more substances are also called reactants, are converted to one or more different substances known as products. A chemical reaction rearranges the constituent atoms of the reactants to create different substances as products. The first chemical reaction is synthesis reaction. It's a type of reaction in which multiple reactants combine to form a single product. Synthesis reactions release energy in the form of heat and light, so they are exothermic. Here is the example of synthesis reaction.
We're going to talk about is the synthesis reaction. These are sometimes called combination reactions. Now, synthesis is just a fancy word that means making, and that's exactly what happens in a synthesis reaction. A compound is made from simpler materials. Here's an example. Carbon comes together with oxygen gas to make carbon dioxide, CO2. What we make in this reaction is more complex than the two simple things that we start with. Here's another example. We take sodium and chlorine gas, Cl2, and that makes sodium chloride, NaCl. What we end up with is more complex than the simple things we started with. Now, a quick word about the equations that I'm using in this lesson. Some of these equations I'm going to be talking about, like this one right here, are unbalanced. So there might not be exactly the same number of atoms on both sides of the equation. Now, normally it's really important to balance equations, but when we're going to be learning about the different types of reactions, the balancing numbers can be a little bit distracting. So here, I just want you to focus on the elements and how they're rearranging or combining with each other in different ways. That being said, a synthesis reaction is one where we start with simple materials and put them together to make something more complex. If we want to represent a synthesis reaction more generally or more generically, we could say that it looks kind of like this. We have A and B combining to make AB. Here, A and B are different elements or they're different compounds coming together to make something more complex. So that's a synthesis reaction.
Second chemical reaction is decomposition reaction. It's a reaction in which a compound breaks down into two or more simpler substances. The general form of decomposition reaction is AB to A plus B. Most decomposition reaction requires an input of energy in form of heat, light, or electricity. And here's the example of decomposition reaction.
In a synthesis reaction, we put things together. In a decomposition reaction, a compound is broken down into simpler compounds or all the way down to the elements that make it up. So in this example here, we have water, H2O, and it's breaking down into hydrogen and oxygen gas. These are the elements that make it up. Now, in a decomposition reaction, you don't have to break things down all the way down to their basic elements. You can also break them down just into simpler compounds. For example, here we have CaCO3, calcium carbonate, and that gets broken down to two simpler compounds, CaO and CO2. It's not like we're taking this and breaking it down into just calcium and just carbon and just oxygen. But still, because these are simpler compounds, it is also a decomposition reaction. So if we wanted to come up with sort of a generalized way to write a decomposition reaction, we could write it like this. AB breaking apart into A plus B, where AB is some kind of compound, and A and B are simpler compounds or elements.
Third type of chemical reaction is combustion reaction. In a combustion reaction, a substance reacts with oxygen from the air. Combustion reaction happens at high temperatures and transfer energy to surroundings as light and heat. Since methane is made up of atoms in carbon and hydrogen, the products of its combustion reaction are oxides of carbon and hydrogen. And here's the example of combustion reaction.
Okay, combustion reactions. Combustion is basically a fancy word for burning. And when something burns, what happens is that a compound containing carbon and hydrogen, and sometimes oxygen, combines with oxygen gas to produce carbon dioxide and water. Here in my example, CH4, which is the chemical formula for methane, that's a type of natural gas, combines with oxygen and it forms carbon dioxide and water, H2O. Now, we can start with different things in a combustion reaction, and as it says here, the compound usually contains carbon and hydrogen. So here is another example of a combustion reaction. This one starts with C3H8, which is the chemical formula for propane, another type of natural gas. And just like with this reaction, we combine C3H8 with O2, and this gives us carbon dioxide and water. So these two reactions are essentially identical, except for the number of carbons and hydrogens in the compound that we start with. It turns out that a lot of things that we burn, like natural gas, diesel, gasoline, are really, really similar, and they only really differ in the number of carbons and hydrogens that are in the molecules that make them up. So combustion reactions for a wide variety of compounds look pretty similar. Now, as this definition says, sometimes we have oxygen in the compound that we're burning. Here is one example of a combustion reaction that has oxygen in it. This is the chemical formula for ethanol or ethyl alcohol, and you can see that just like these, it has lots of carbons and hydrogens, except it also has oxygen as well. But that's no big deal because it combusts just like the other two by combining with oxygen and making CO2 and H2O. So if we wanted to come up with a general way to write the formula for a combustion reaction, it might look a little bit like this. We start out with something that has carbon and hydrogen in it, and we can have different numbers of carbons and hydrogens. So that's why I put this X and Y here, because the number of carbons and hydrogens varies, and it doesn't really matter either. Sometimes the compound has oxygen in it, which is why I put the oxygen here in parentheses. We take this compound, it combines with oxygen, and it produces carbon dioxide and water. So this here is the generic general equation for a combustion reaction.
Here's the 4 types of chemical reaction. Single replacement reaction. A single replacement reaction, sometimes called single displacement reaction, is a reaction in which one element is substituted for another element in a compound. The starting materials are always pure elements such as pure zinc, metals, or hydrogen gas, plus an aqueous compound. Here's an example of single replacement reaction.
And in a minute, you'll see why. So in a single replacement reaction, what happens is that one element that starts out by itself replaces another element in a compound, kicking it out. And here's an example to show you what I mean. We start out with iron, Fe, which is this element that's by itself. And iron combines with CuCl2, which is copper chloride. Okay, so copper and chloride are paired up here. But what happens is iron kicks out the copper, the Cu. So the Cu ends up by itself, and the Fe, the iron, takes the place of that copper. So now the iron and the Cl, they are now paired up. Now I like to use a dance analogy to explain this, and it reminds me of something that happened all the time in high school. Here's what's going on. We have a dancing couple, the purple and the green. And they're so happy dancing together, or at least the purple guy is pretty happy dancing. And then red comes along, and red is like, hey purple, I'm so much cooler, get out of the way, I want to dance with green. And so poor purple gets booted out, and red ends up dancing with green. Purple ends up all by himself, standing up against the wall, pretending to text, pretending to play a game on his cell phone, but you know, he's really actually sad because he's just been booted from this dancing couple. So you'll see that this is exactly what's going on in the single replacement reaction, right? Fe, iron, is like red here. Coming up to a dancing couple of Cu and Cl, it boots out Cu, Cu ends up by itself, and then red, iron, takes the place that Cu had, and iron ends up paired with Cl. Here's one more example of a single replacement reaction. You can see how this works. Cu in this case is the red character, and Cu goes to a dancing couple of Ag, silver, and nitrate, AgNO3. Cu boots out Ag, So Ag ends up by itself, and Cu takes Ag's place by pairing up with NO3. So that is how a single replacement reaction happens. And a generalized reaction for that would look like A, which is the element that starts out by itself, plus BC, that's the dancing couple, and then that gives us B by itself, which is this element that got booted out, and then A and C ending up paired together. So that's a single replacement reaction.
The last type of chemical reaction is double replacement reaction. Double replacement reaction exchange the cations or anions of two ionic compounds. A precipitation reaction is a double replacement reaction in which one product is a solid precipitate. Solubility rules are used to predict whether some double replacement reaction will occur. Here's the example of double replacement reaction.
Here's the double replacement reaction. Now I should mention that single and double replacement reactions are sometimes also called single displacement and double displacement, just in case your teacher or textbook uses a different term for them. Okay, so double replacement reactions are not nearly as heartbreaking as single replacement reactions. Here's why. Because in a double replacement reaction, what happens is the positive and negative ions in two compounds just switch places. Nobody gets kicked out in a double replacement reaction. In a double replacement reaction, it's just like you have two different pairs of dancing couples, and the red, which used to be with the gray, ends up with the green, and the purple, which used to be with the green, ends up with the gray. Nobody gets kicked out, nobody's sat up against the wall with their cell phones, we're just switching dancing partners. So here is a chemical equation that shows a double replacement reaction. We start out with Ba and Cl together, and then Na and SO4 together, and they just switch places. So Ba ends up with SO4, there it is, and Na ends up with Cl, there it is right there. All of these compounds are ionic, which means that we can break them down into the positive and negative ions that they're made up of. So here, the positive ions are in purple, and the negative ions are in green. And as you can see, the positive and the negative just switch places. So Ba2 plus and Cl minus were initially paired up. But then Ba goes and it gets switched. It finds a new dancing partner. It has to find the other negative ion, right? So the other negative ion here is SO4 2 minus. So Ba2 plus and SO4 2 minus end up together, making BaSO4. And then sodium, Na1 plus, has to find the other negative ion, which here is Cl minus, and they end up paired up over here, Na1 plus and Cl1 minus, making NaCl. Here's another example of a double replacement reaction, okay? I'll break this down into its ions right away, and we get this. We start with K plus and Br minus paired together, and Ag1 plus and NO3 minus paired together, and then they just switch the positive and negative. So K plus goes and finds the other negative ion, which here is NO3 minus. K plus and NO3 minus end up together, and Ag1 plus, silver, looks for the other negative ion, which is Br1 minus, and Ag1 plus and Br1 minus end up paired up together, making AgBr. So that is a double replacement reaction, and if we wanted to come up with a general or generic way to explain it, we could use this reaction here, where we have AB, where A and B are paired up, plus CD, where C and D are paired up, and then they switch partners to give us AD and BC. So that is a double replacement reaction.